We are continuing along in section 16.8. We have one last thing to talk about in this section. The last thing that we want to talk about is acetal hydrolysis. Or you might see this written as hydrolysis of an acetal. So the acetal hydrolysis is basically this reaction in reverse, just going in the other direction. So starting out here, starting at the acetal and backing up to make a ketone or aldehyde and some alcohols. And the same for the hemiacetal, starting at a hemiacetal and backing it up to make an aldehyde or a ketone. Now, since we have seen this reaction in the forward direction with these specific examples, I'm going to do the hydrolysis reaction using these exact same examples because we know exactly where we're supposed to be going with this reaction. So for the hydrolysis reaction, I am going to use the same acetal that we made in our example. The acetal hydrolysis reaction is also acid catalyzed. It uses the same reagent, which is crazy. So it is pretty tricky for students to figure out what's the ketone that came from this acetal and what do the alcohols look like? Like what are the structures of these products? It is not an easy thing to do. So I'm going to give you some shortcuts that will hopefully help you make good predictions about what the products of this reaction look like. So the first thing that I want you to do when you're doing this hydrolysis reaction is to find the OCO of the acetal group or the hemiacetal group. It's not going to matter whether we're talking about an acetal or a hemiacetal. I want you to find that part. And I want you to remember that these two carbon-oxygen bonds, these were the bonds that we said, let's open them up like a flower. We're going to open them up like a flower. So what I want you to do is close those bonds back up. I'm going to redraw it over here. What I want you to do is take these bonds and I want you to just close them back up. Like that. Just close them up. And I'm actually going to move this. I wonder if I can just cut and paste it, move it out of the way. Oh, I can. Look at that's so cool. Move that out of the way. Just get it out of the way. Over here, we have these fragments of the alcohols that we just chopped right off of that acetal, and we're going to fix them by just putting their OHs right back onto them. Remember when we were adding the alcohols, when we were doing this reaction in the forward direction, we were just focusing on what's the carbon chain, and we were ditching these OH groups in the process. So now we're just putting those OH groups right back on again. And that's kind of not too bad, although I know that when I'm just explaining it and showing you how to do it, it makes it feel a lot easier than it is when you start doing it yourself. So let's do another example. Okay, so we are going to, I'm going to start by redrawing. I'm going to be really careful to make sure that I don't leave anything out. And then what I want you to do is I want you to remember when we synthesized this, when we were going in the forward direction, I wanted you to take this OCO. This was the part that you opened up like a flower. You opened that up. So now what I want you to do is take that OCO and snap it back shut. Actually, what I need to do is get this hydrogen out of the way because it's about to get snapped right down onto it. So I'm just going to move the hydrogen to a different angle. That's totally allowed. You can do that. So I'm going to take this OCO and I am going to snap that part of the molecule back shut, just like that. And those fragments that I just broke off, just going to add a couple OHs to it. So this reaction is making 3 products. Let me rewrite them. It's making this alcohol. That looks really weird, drawn in line structure, but there it is. It's making this ketone, this guy right here that I've cleaned up nice. And then it's making another alcohol. Also looks kind of weird in line structure. There it is. So we get 3 different products from this reaction. Let's try another one. We've got this guy. And this one we're going to make it a little uneven, make it a little exciting. Acid catalyzed. Okay, so I want you to start, redraw, don't change anything, make sure you don't lose anything. It's so easy to lose carbons. I want you to find your OCO. Find your OCO. And remember, that is the part of the molecule that you opened right up like a flower. So what I want you to do is take that part of the molecule and I want you to snap it shut. Like that. And I know I've got cooler tricks than what you have with paper. So I'm moving that clean, nice part of the molecule out of the way. Back to those fragments, we're going to add an OH to both of them. Look at how well that worked. I'm going to spread these guys out. No. Spread out. 3 molecules. There we go. What if we did one? Let's do one more. One more, and this time it's going to be a hemiacetal, just so we can see what that would look like. And then I think you'll be ready to try this on sapling. So first, number 1, you redraw without changing anything. Make sure you get all of your atoms in the right spot, all of your carbons are in the right spot. That's your step 1. Step 2, find your OCO. Find your OCO. That's the bond that you had opened up like a flower. So now I want you to take that OCO and I want you to snap it back shut. And I'm going to get it out of the way. Now this looks really weird what we have left over here, but don't do anything different. We're adding an OH to one, we're adding an OH to the other, which is the same thing as water. That's it. That's all there is to it.